All right, let's dive right into this explainer. Today, we're going to untangle the incredibly complex and frankly kind of overwhelming landscape of front-end app development in 2026. Welcome to episode 11, where we are tackling this massive, unavoidable decision that literally every technical lead has to make right now, choosing between native code like Swift and Kotlin, cross-platform frameworks like Flutter and React Native, or wildcard alert using game engines like Unity for mainstream app development.
So you might be wondering, why are we focusing so heavily on this today? Well, to put this into perspective, by 2026, mobile apps are expected to pull in an absolutely mind-boggling $935 billion in revenue. That means the financial stakes of picking the right architectural framework for your project, they have literally never been higher. Make the wrong call here, and it completely messes up your hiring costs, your onboarding speed, your long-term maintenance, and most importantly, your user experience. So to navigate this, we're taking a structured tool belt tour through native, cross-platform, and game engine options, breaking down all the latest data so you can map the absolute best tech to your specific business scenario.
Here's our agenda for today. We're going to cover the app development dilemma, the power of native, the cross-platform contenders, the game engine wildcard, performance and cost trade-offs, and wrap up with making your final choice. Let's get right into it.
Starting with Section 1. The app development dilemma.
Okay, so every tech lead faces this fundamental problem, right? You're basically playing this constant game of tug-of-war. On one side, you have development speed and labor costs. On the other, you have app performance and user experience. It's the classic dilemma. Native development means building an app specifically for one single platform, like just iOS or just Android, using their specific languages. Now, this gives you absolute peak performance, but the catch, you need two totally separate teams and two code bases. Cross-platform, on the other hand, lets you write your code once and just deploy it everywhere. Saves a ton of time and labor. But, and it's a big but, while you avoid maintaining two code bases, these cross-platform solutions usually introduce layers of abstraction, and those layers can really end up costing you in runtime performance.
Moving on to Section 2, the power of native.
Let's get as close to the metal as possible. Native development gives you unimpeded, total access to all system features. This is the absolute baseline for maximum performance. Basically, this is where you go when compromising on speed just isn't an option for you. When we talk about native in 2026, we're really looking at Swift for Apple and Kotlin for Android. Swift compiles directly to native machine code via LLVM. There's no middleman runtime layer, so it takes highly optimized advantage of Apple's M-series silicon. It just flies. Now, Kotlin on Android uses the Android Runtime, or ART, with ahead-of-time compilation. It pre-compiles the bytecode right when you install the app, so you aren't paying any warm-up costs when you open it. Both are incredibly fast, null-safe, and give you the absolute deepest integration with UI frameworks like SwiftUI and Jetpack Compose.
Now here's what's genuinely exciting. Native gives you all the predictable memory management and first-day access to new OS features, for sure. But Kotlin Multi-Platform, or KMP, has matured into a massive, absolute game-changer in 2026. Get this. KMP lets you write your shared business logic, stuff like your data models and networking, just one time. But you get to keep the UI natively rendered on both iOS and Android. It essentially slashes your team's sizing constraints, but you don't sacrifice even an ounce of that flawless native feel. It's really the best of both worlds.
All right, Section 3, the cross-platform contenders.
So say you really need a true single code base that handles both the logic and the UI. That's when you move up a layer of abstraction and look at the massive efficiency gains of the cross-platform heavyweights. The two undisputed kings right now are Flutter and React Native. And honestly, they take fundamentally different approaches to solving this problem. Flutter, which uses the Dart language, basically acts like an artist drawing every single pixel itself using its impeller rendering engine. It completely bypasses the native OS UI components to give you strict, pixel-perfect consistency across mobile, web, and desktop. React Native, on the flip side, uses JavaScript or TypeScript, and with its modern Fabric architecture, it actually maps directly to the device's native components. So an iOS button in React Native, that is a real, actual iOS button. But when we look at real-world adoption, the numbers tell a pretty fascinating story. Flutter definitely has a larger, super enthusiastic developer community and tons of GitHub stars. But if we look at the data from AppBrain, React Native holds a massive, massive lead in actual production install volume for top-tier apps. We're talking 16.99% of installs among the top Android apps, compared to less than 1%, 0.84% for Flutter. Why? Well, it usually comes down to React Native having a much lower barrier to entry if you already have a team of web developers. Plus, its incredibly deep integration with the whole massive JavaScript ecosystem.
Let's look at Section 4, the Game Engine Wildcard.
Now we're heading into some really specialized wildcard territory, using a 3D game engine for mainstream apps. This is actually gaining some serious traction for specific use cases. I know, you probably think Unity is just for gaming, right? But it's actually an incredible tool for mainstream apps that need to do some heavy visual lifting. Think about educational tools like Shapes that help kids visualize complex 3D geometry, or AR apps like Kvaptek, where you can literally redesign your living room in real time. Unity is natively cross-platform, and it absolutely shines for anything involving mixed reality, interactive simulations, or real-time 3D rendering. Traditional UI frameworks like React Native or Swift UI would just choke on that kind of stuff. But I hear you asking, what about the battery drain? Let's address the elephant in the room, game bloat. Developers working in the trenches point out a super important detail. The old problem with Unity was that it refreshed every single frame no matter what, which obviously nuked your battery for a simple non-game app. But Unity's on-demand rendering feature completely solves this. It actually lets the engine stop needlessly refreshing when the screen is static. So, as developers are noting, if you have modern hardware and optimize it properly, Unity is highly viable for utility apps now.
Which brings us to Section 5, performance and cost trade-offs.
Okay, so convenience is great and all, but what is the actual cost of that abstraction? We need to look at the empirical data when these setups are put under heavy stress. A recent academic thesis tested exactly this. They built two completely functionally identical complex route planning apps, one in native Android, one in Flutter. The results? Kind of stark, actually. They both handled network data fine, but the native Android app used 13.8% less CPU and roughly 30% less estimated battery power than Flutter. The native app also cleared out its memory garbage incredibly well, while the Flutter app showed the sustained creeping memory growth over time.
And this right here perfectly illustrates the hidden tax of that cross-platform abstraction layer. In an intensive UI rendering test, the native Android app held strong at a super smooth average of 55 frames per second. The Flutter app, dealing with that heavy rendering load, really lagged. It dropped down to an average of just 33.34 frames per second.
But hold on, because even more shockingly, that same test looked at the jank rate. Jank is basically when the system misses a frame and the user feels that annoying stutter. The native app? Very low jank rate, just 8.25%. Flutter, on the other hand, hit a 55.69% jank rate under heavy load. Guys, that is 575% worse than the native build. The result is a visibly choppy experience. When you absolutely cannot compromise on peak performance, the data unequivocally says, go native.
Finally, Section 6, making your final choice. Let's synthesize all this into a practical framework for you and your team. Consider this your 2026 cheat sheet. Choose native Swift or Kotlin when flawless performance, AR, or deep OS integration is not negotiable. Just be ready to accept the higher cost of managing two code bases. Choose React Native if you already have a ton of JavaScript talent, need a fast MVP, or really want over-the-air updates. Go with Flutter if you need pixel-perfect, custom branding across mobile, web, and desktop all from one codebase. And finally, choose Unity when 3D rendering or interactive simulations are the core of your app. But remember, building standard menus in text UI and a game engine is going to be a massive headache. At the end of the day, there is absolutely no universal silver bullet here. An architecture that looks flawless on paper is going to be a complete disaster if your team doesn't have the skills to actually maintain it. Thanks for hanging out for this explainer. We really hope it helps you build better things. But before you kick off that next big project, I want you to ask yourself, what specific constraints and trade-offs is your business uniquely positioned to accept, and which framework actually aligns with how your team already works today, rather than just picking the one that wins on a benchmark?